Hi there, this is Austin, and I'm going to talk to you today about my topic, cryogenics. So if you look here, cryogenics, what is it? Well, cryogenics is a study of materials that are processed at low temperatures. But how low of a temperature are we talking about? Well, the term a cryogenic temperature can be applied to all temperatures that are below the boiling point of oxygen, which is negative 183 degrees Celsius, which is pretty cold. Now, at these temperatures, substances, they begin to behave strangely, and there are many changes in physical characteristics of a material, such as viscosity, conductivity and magnetivity, and density. There are obviously many more, but these are the three I'm going to talk to you about today. So viscosity. Viscosity is the ability of an object to flow. Less viscosity equals easier to flow. And today I'm going to talk to you about liquid helium, which has a viscosity of near zero when it's liquefied. What does this mean? It means that it can pretty much flow through any gap. Let's see a video on this. Alright, so this is before, this is after it's liquefied into liquid helium. You'll begin to notice that before it didn't drip, but now it is dripping. Yeah. This is because of the zero viscosity of helium. There are like tiny gaps here. Now if you see here, obviously there's a lot flowing through, which is one of the wonders of liquid helium. Now this is what the creator of the video here describes as helium tears. It's when the liquid helium climbs up through the container and drips back down to form a tear of liquid helium dropping down, which is example of the viscosity of helium. Now, onto conductivity and magnetivity. So that's a picture. So superconductors, you must have heard of this before. So what superconductors are conductors with basically no electrical resistance. They occur when metals are cooled by cryogens, which are liquefied gases that are used as coolants, such as liquid nitrogen. Now, superconductivity works, it can basically be explained through the BCS theory, which involves electrons forming Cooper pairs in the crystal lattice. It moves through it, and which is the main reason why it doesn't experience resistance, because it's not bumping into anything really. Onto magnetivity. So there's an important effect of materials when at low temperatures. It's the Messner effect. So this is before a temperature is above the critical temperature of a material. The magnetic field just goes through the material. It doesn't stop. It just goes through. However, when the temperature is below the critical temperature of a material, then you'll notice that the magnetic field here is repulsed by the material, so meaning that it basically goes around it, if you will. What does this do though? This effect is used to levitate superconducting trains, which can travel at a speed of 500 miles per hour, which is pretty fast. Now, onto density. How can cryogenics affect the density of a material? Well, many industries, they use cryogenics to increase the resistance, wear resistance, of a material. They do it, this is because after supercooling a material, it has a denser metallurgical structure, This is because of the denser molecular structure, which is caused by the cold temperature taking away molecular energy inside the molecular structure, because there is less energy at cryogenic temperatures, obviously. So let's look at an example. So the processing of retained austenite to martensite. This is before and this is after. As we can see, the after supercooling a material, the molecules are much more dense than compared to this rather sparse distribution of materials over here. Now, so which is proof that this will cause in martensite being much more dense and therefore harder to make a scratch on, which is the whole concept behind the wear resistance. Now, Canada and society. How does cryogenics affect the society? Well, nowadays we're thinking about saving energy and doing green things to save energy. Well, superconductors, they can come in with that. If we can make an effective superconductor, then we can basically save a lot of energy. Now, Canadian initiative. What has Canada done in cryogenics that has helped the world or something? Well, there is a Canadian company called Cryotron, which is they are pioneers in manufacturing wear-resistant materials, cryogenic equipment. So by supercooling it, they create a material that is very wear-resistant. Now, moving on to risks and benefits. There are a lot of benefits, as we mentioned, through superconductivity, such as superconductivity. Well, it can obviously help the environment by a lot if we can find an effective way, an efficient way to make a superconductor conduct electricity, since there will be basically no energy loss. And it will save a lot of money as well, because obviously companies won't have to produce as much electricity as before. Now, there's the cryopreservation of bodies, which is preserving a body using supercooling after the body has died. And also cryosurgery, which is helped to remove cancers and tumors in a surgery. Also, the creation of wear resistant materials can also save industries a lot of money. But what are some risks of cryogenics? Well, there are many explosions due to the pressure exerted on the vaporizing gas. There are also injuries due to cold, because obviously cryogenics is a cold environment to endure. Obviously, the problem of waste products. So where are we going to put the waste products of cryogenic processing? Now, moving on to technological products and safety concerns. So obviously cryogens are a very technological product of cryogenics. They include products such as liquid helium, liquid nitrogen, and liquid helium. Also, for safety concerns, obviously cryogenics is very cold, and we want to kind of stay away and be careful, be aware to not be injured by the cold. Now, this is my citations list, and yeah, I hope you guys enjoyed my video. Completely man-made, I guess. And yeah, comment, I guess, subscribe, I don't know. And yeah, good job. Later.